So we'll understand the periodicity of discrete time signals. To understand it, just have a recap of what we had done in case of continuous time signals. If you remember, we expressed xt as e to the power j omega 0 t. C was taken constant and this was imaginary. And if t0 is the time period, then we know this is equal to j omega 0 t plus t. Okay, so this is we know, and this is actually equal to e to the power j omega 0 t into e to the power j omega 0 t0. For this to be periodic, this function has to be equal to 1, that is a j omega 0 t0 should be equal to 1, from where we define this as t0 into omega 0 equal to 2 pi. If this is 2 pi, this will be equal to 1. So from here we found t0 equal to 2 pi by omega 0 or omega 0 equal to 2 pi by t0. Now in case of continuous time signals, from this expression there are 2-3 things that is very clear. That rate of oscillation, that is angular frequency, is distinct for every distinct value of, or I should say like this, for every distinct value of omega 0, the signal is different. That is, xt is distinct for every distinct value of omega 0. If it is 1, it has one value. If it is 2, it has another value. If it is 3, there is another value. So this is the first thing that we observe. Second is that as the rate of oscillation increases, time period decreases. So there are 2 important things to understand from here. First is that omega 0 can go up to infinity. That is, you keep increasing omega 0 and your signal will keep increasing. That is, your rate of oscillation keeps on increasing. And second is that for every value of omega 0, the signal is periodic. Clear? So signal is periodic for all omega 0. So these are the 2 things that we understand from here. Now let's understand our discrete time signals. Do they behave in the same manner or do they differ? To tell you, they differ a lot. Though there are similarities, there are differences also. See, a j omega 0 n. This is how we represent periodic discrete signal. Now, what if I say j omega 0 plus 2 pi into n? What is the value? This will be e j omega 0 n, that is the original signal, into e j 2 pi n. What is this? Cos 2 pi n plus j sin 2 pi n. Cos 2 pi is 1. That is, this is equal to 1. So from here what we get? This is equal to 1. So actually what we get is the original signal. This means that for all values of omega 0, the signal will have the same value for omega 0 plus 2 pi. From this it is clear. That is, if I draw a graph, see, like this. This is a graph where this is omega, this axis is omega, and this axis is xn. Don't confuse it with n. Just this is for your understanding only. And if this is 0, this is pi, this is 2 pi. So what we understand from this is, see, from here we understand that if the value of omega is this at, sorry, not this, this is omega 0. So if the value of xn, let's say it is x1. If it is x1 at omega 0, so you add 2 pi to it, that is here, again you will have x1. That is, signal keeps on repeating for omega 0 plus 2 pi, or you can say even multiples of 2 pi. You can put omega 0 plus 2 m pi also, where m is equal to 0, 1, 2 and all, not 1, even multiples 0, 2, 4. So the signal will keep repeating. In the case of continuous time, you can have any value of omega, and for any value of omega, the signal xt was distinct. That for every value of omega, the signal was distinct. But here it keeps repeating. That is, at omega 0, then at omega 0 plus 2 pi, then omega 0 plus 4 pi, you will get the same signal. This is the first observation. And this is the difference between discrete and continuous time signal. Second is, if you monitor it closely, what happens is that between 0 and 2 pi, you'll have maximum value of xn at omega 0 equal to pi, and it keeps increasing till it reaches omega 0 equal to pi, and then again it starts decreasing. The signal starts decreasing till it reaches this. Let's say this is the value at omega equal to 0. That is at omega 0 equal to 0, 2 pi or 2 m pi. Sorry, we had used 2, so we can use 1 here. 1, 2, 3, anything. So at these value, the frequency, the value of the signal at these values of omega will be lowest. Clear? And at omega 0 equal to pi or 2n plus 1 pi, that is odd multiples of pi, where let's say this is m1, so where m1 is again 1, 2, 3, 4, whatever value you have. So at odd multiples, that is at this point, or if this is 3 pi, you will have the maximum value of this signal at pi or odd multiples of pi. Okay, these are the two observations and two dissimilarities between continuous time and discrete time. So from here what we understand, we need to choose a value of omega 0 between 0 and 2 pi. If we know a value of omega 0 between 0 and 2 pi, the value of the signal at that is outside of this frequency 2 pi, 3 pi, 4, 5 pi, we know it is omega 0 plus 2 pi will have the same signal. So this is a very important distinction with respect to continuous time signals, where for every value of omega 0 you can keep on increasing omega 0, and for every distinct value of omega 0 you will have a different signal. Okay, this is clear. Now let's understand one more thing. What is the value of the signal at omega 0 equal to pi? See, at omega 0 equal to pi you will have j pi n. This is minus 1 to the power n. This is equal to minus 1 cos pi minus 1 to the power n. That is at omega equal to omega 0, sorry, at pi, omega 0 equal to pi, your signal values keep on oscillating. That is, if, now I'm using, now let's have this as n scale. Then if our signal is at omega 0, this will keep oscillating. Every signal will be, one signal will be in positive direction, one in negative, like this. So at omega equal to omega 0, at omega 0 equal to pi, the signal will oscillate. Okay. Now the next thing, how to find the fundamental frequency of a discrete time signal, discrete time exponential signal or sinusoidal signal. How to find that? Let that be n, capital N. So you know it very well. We'll do this, and this is equal to aj omega 0 n into aj omega 0 capital N. So for this to be periodic, we know this signal has to be, has to be equal to 1. This should be equal to 1. So from here what you get, this should be equal to omega 0 into n. This should be equal to 2 pi into some value of m. We have seen it repeats after 2 pi, where m is 1, 2, 3, 4, anything. Okay. So from here we get a very important relation, that is omega 0 is equal to m into 2 pi by n. Now see, this is distinct from continuous time, where it was omega 0 was 2 pi by t simply. Here we have this ratio. Similarly, we can have n is m into 2 pi by omega 0. So fundamental frequency is a multiple of 2 pi by omega 0 here. There it was simply 2 pi by omega 0. So one very important relation from this we get, that is omega 0 by 2 pi is equal to m by n. Now what does this signify? This signifies that the signal will be periodic only when m by n is rational. That is, this has to be rational, this quantity has to be rational for this signal to be periodic. What is the meaning? Let's say our omega 0 is equal to 10 pi. Then our ratio m by n will be 10 pi by 2 pi. That is 5. It is a rational number. Therefore, this signal, when omega 0 is equal to 10 pi, it will be periodic. But what if this is 10? If omega 0 is 10, our answer will be 5 by pi, which is not a rational number. That is, at omega 0 equal to 10, the signal will not be periodic. This is in contrast to continuous time signal, but you'll have to understand this. When m by n ratio is rational, this is periodic. When it is not rational, pi by pi is not rational, then the signal is not periodic. That is, if we have cos, say cos omega 0, this sorry, not t, n, cos omega 0 n, if this is the signal, our signal is this cos omega 0 n, this means at omega 0 equal to 10 the signal is not periodic, even when it is a cosine function, but when omega 0 is 10 pi, this will be periodic. This you should understand properly. Try to write down these things in your copy and try to understand it, revise it 2-3 times, then you'll get the gist of this. Okay, so this is a very important relation, omega 0 by 2 pi equal to m by n. Now we have seen continuous time signals, we have seen discrete time signals, sinusoidal signals, periodic signals. Now let's have a chart where we have difference between the two. So let's say this is the continuous time signal and this is discrete time signal. You know, it is represented as xn equal to aj omega 0 n, and this is represented as, if this is xt, it is ej omega 0 t. So the first difference is xt has distinct value for distinct values of omega 0. So you have different omega 0, the value of the signal will be different. But in the case of discrete time signals, number one, xn is repeated, the value of xn, xn is repeated at omega 0 equal to omega 0 plus 2 pi. This is just a representation, you should not think this is equal to this. So whatever value xn has at omega 0, the value will be same at omega 0 plus 2 pi. This we have seen. Okay. Now second difference is that this signal, continuous time signal, is periodic for any value of omega 0. You can have any value of omega 0. Here it is periodic, we just saw, it is periodic when this is satisfied. Omega 0 by 2 pi is m by n, this ratio has to be rational, then only the signal will be periodic. These are the two differences. Third difference is that its fundamental frequency is omega 0. But what is the fundamental frequency of this discrete signal? It is not omega 0, it is omega 0 by m. Okay, this is the third difference. Now fourth, the fourth difference is our fundamental time period. It is undefined for omega 0 equal to 0. Here also it is same. Fourth one, that this is undefined for omega 0 equal to 0. But the second point is t0 is defined for omega 0 not equal to 0. Here also your fundamental frequency, it is defined for omega 0 not equal to 0. But what are the values? Here t0 is simply 2 pi by omega 0. That is, it is distinct for distinct values of omega 0. But what is t0 here? t0 here will be, see, not t0, n0. n0 from here you get is equal to m into 2 pi by omega 0. That is, there are distinct values. It is not a single value. That is, not for every distinct value of omega 0, it is not same. It also depends on this particular scalar. That is the number. That is which cycle you are in. So it keeps on changing. For every 2 pi, after every 2 pi, it repeats. Okay, so these are the differences between continuous time and discrete time signal. You should understand them.